Hello, Mr. San. So I'm Peter Phone, right? And yeah, today I'll presenting you about my work, energy, and power. So let's begin my work, energy, and power. We'll start with vocabulary. Work is when a net force is exerted on an object while the object moves a certain distance. The object will be accelerated and its velocity will increase. Next is joule. Joule is a SI unit of work. Next is energy. This property is the ability of an object to produce a change in itself or a world around it. Next is world energy theorem, which is when work is done on a system, the result is a change in the system's energy. Next is kinetic energy, which is the energy resulting from motion. And the translational kinetic energy, which is an energy due to motion of a system's centers of mass. And next is power, which is the rate at which energy is transformed. And watts is the SI unit of power. And we will talk about formula, which is a work. So first one is work equal force times distance times cos theta. And next is force times distance equal 1/2 times time m time v final square minus 1/2 times m times v initial square. And next is the work energy theorem, which is work equal change in energy. So and next is energy. Energy is E equal 1/2 times m times v square. And translational kinetic energy is kinetic energy equal 1/2 times m times v over square. And next is power, which is power equal change in time over time. Power equal change in energy over time. And the units are joules equal work and watts equal power. And the essential questions: what is work? It is when a net force is exerted on an object while the object moves a certain distance. The object will be accelerated and its velocity will increase. And what is energy? This property is the ability of an object to produce a change. And how are work and energy related? It is related in work energy theorem. When work is done on the system, the result is a change in the system's energy. And the difference and this is an example. It is how much work is done if I push refrigerator for 20 meters with 10 Newton and the angle of 35 degrees from horizontal. It will be work equal F times D times cos theta equal 10 times 20 times cos 35, which is equal to 163.8 joule. And here's a demonstration. And here's just a short clip of what I do. First I use I'll drag my charger horizontally, but then I will drag it with some angle which I predicted is like I use the angle that I use is probably about like 30 degrees. And here's my small lab at home. So so the answer for force, the answer for work with angle and without angle is quite different. In my lab that I do, like work with no angle is like 0.055 Newton meter, but but work with angle is actually 0.02 Newton times meter, so it's quite different. But the force they went in the same way but different in work. And thanks for listening and thank you for your attention too. Bye bye.